Okay, so now let's finish this question. So we know it's 0.2 grams for every 100 milliliters, right? And now we just convert that into portions. So we have times, so we know there for every 1 gram there are 1,000 milliliters, or sorry, milligrams. So canceling these out, multiplying should give us, I believe, 2 milligrams per milliliter once we divide. Okay. So why don't you guys try questions 6, 7, and 8 based off this information. Just try 6, 7, and 8. I'll give you a quick pause, so 3, 2, 1, and try these out. All right, so hopefully you guys tried them out. Now let's do them together. So 6 is very similar to the one above. How many grams of solute? So notice it's grams, right? So we know it's dry already. Solute, so solute means drug, right? Well, you need to prepare 1 liter of 110 solution. So you always start what you're given. So 1 liter is 1 L, right? And, well, how do we express this? Well, it's dry because it's grams. So we know for every 1 gram, there are 10 milliliters. Well, here's a problem, right? Liters to milliliters doesn't work, so I have to convert this first to milliliters. So we know there's, for every 1 liter, there are 1,000 milliliters, so this is now 1,000 milliliters, and now we can use a portion. Times, every 10 milliliters, there's 1 gram. Okay, now we just divide, so therefore this is going to be 100 grams in 1 liter. All right, let's try 7. So given that dextrose in water has a strength of 25 grams per 50 milliliters, so they give us already the strength of the drug, right? How many grams of it are contained in 30 milliliters of the solution? Okay, well, we always start with a given, so we're given 30 milliliters of solution, and we'll look for grams, right? We want the drug, so we want drug, and we're given solution. So 30 milliliters. We know the strength of the drug is 50 milliliters for every 25 grams. So multiplying and dividing should give us 15 grams. All right, and the last one on the page, given that iodine liquid, so they give us a hint, right? Given that iodine liquid in water has strength of 65%, how many milliliters of iodine are in 250 milliliters of this solution? Now, this is a really big trick question when it comes to it. The reason why I say that is when it comes to your homework questions and your book itself, if you guys do references, they're gonna give you this question with a little hint. They're not gonna tell you this here. Okay. Now they're also not gonna tell you this kind of stuff. So first off, we have liquid, right? So it's on the back portion. Next thing is, what does this 250 mean? Is that 250 solution or drug? Okay. Well, this actually is the solution. So we're given solution and we're asked to find milliliters of drug. That's the key thing when it comes to it. That's what makes liquid so difficult, because you're not sure what's being asked of you to find, because they're both liquid formats. So you got to be very careful how this is actually formatted. So we're given 250 milliliters of solution, which means if this 65%, this is 65 milliliters of drug over 100 milliliters of solution. So since we're given solution, that means solution must be at the bottom, and the 65 must be at the top. So therefore now multiplying, this is 162.5 milliliters of drug. Or in this case, we were talking about iodine. So that's what we got to be very aware when it comes to liquid upon liquid, when it comes to the strength of drugs, because you got to be very careful what's either, what's given to you in the question. Is it, the solution given to you, or is it drug solution, and what's being asked of you also as well. Okay? So here's another example that's pretty tricky as well. Number 9 back here. Okay? So how would you prepare 200 milliliters of 120 Clorox liquid solution? Okay, so again, this is how your homework is going to be asked. So the next sentence is what I'm me trying to help you, but that sentence is it. That's all they're going to ask you. So I'll read it again. How would you prepare 200 milliliters of 120 Clorox liquid solution? Okay. So basically what they're asking this question is, so in other words, how many milliliters of Clorox do you need to prepare 200 milliliters of solution? Okay. Which means this is actually solution and we're looking for drug. Okay, so that's the key thing. It's a very trick question when it comes to it. Because essentially what they're saying is this 200 milliliters actually is the solution given to you here. Okay, so it's very similar, just like the last question. So we're given 200 milliliters of solution, which means corresponding to this 120, right? This 20 is at the bottom because that's solution, and this one's on top because that's drug. That's what we're asked to find. So now, essentially just dividing gives us 100 milliliters of Clorox, or the drug we wanted. So you got to be very, very careful when it comes to liquid. It's a trick question. Okay? So once you guys try 10, using this template to help you guys out. Okay? So go ahead and try 10 real quick. So 3, 2, 1. All right, go for it. So calculate the number of milliliters of 5% methanol solution that contains 6 grams of methanol. So notice this is dry, right? Because it's giving us a gram. So that's off the bat. So we know this for sure is going to be drug given to us, which means by default we're looking for solution, right? We want the solution, how many milliliters, right? That's what we want, solution. So we're given drug, so 6 grams. And now we're given 5%. So we know 5% is 5 grams for every 100 milliliters. And since we want milliliters, so that means grams have to be at the bottom. And now we cancel out, and it should be 120 milliliters of solution do we actually need. Okay. Okay. So just a quick reminder, I cannot stress this enough, right? So we'll pop these up a little bit. Is when it comes to liquid solutes, the entire equal solution is, solute plus solvent, because there's some big questions be vice versa when it comes to it. So let's look at number 11. So how many milliliters of 1/6 strength hydrogen peroxide can be made from 150 milliliters of hydrogen peroxide? Now, here's the thing I want you guys to actually look at. What is this given to you? Is this solution or is this drug? Go ahead and read it. Take your time when it comes to it. Okay. Now, here's the hint. This actually is drug, so hopefully you guys got it. Now, the reason why it's drug is because it did not say solution, right? It's the actual drug being involved, hydrogen peroxide. Now, if it said made from 150 milliliters of hydrogen peroxide solution, that's going to be your solution. So since it didn't say that, this is actually your drug, which means we want in milliliters, we want solution. That's what we really want in this question. Okay? So since we're given 150 milliliters of drug, now, again, going back to this 1/6, but this is saying one milliliter of drug over 6 milliliters of solution. So since we want to cancel out the drug, therefore the 1 has to be at the actual bottom. And the 6 goes on top. So that's why writing liquid is pretty difficult because, when it comes to this. So multiplying this out should give you 90 milliliters of solution. I'm sorry, 900 milliliters of solution. Okay. Right, so last one here, number 12. How would you prepare 350 milliliters of 3/5 pure iodine solution? So again, think about it. Going to this concept, what is this 350 is? Is that drug or solution given to you? So try to think of the hint I told you guys here. So hopefully you said solution. Here was your hint, right? At the very end it says solution, which means we want pure iodine, we want drug. In this case, the complete opposite of the last question here. Okay? So we're given 350 milliliters of solution. times. So 3/5. So that means it's drug over solution. So we need drug on top. So 3 milliliters of drug over 5 milliliters of solution. So those cancel. So multiply and divide should hopefully give you 210 milliliters of pure iodine, because that is what we want with the drug itself. Okay, so just got to be very wary how the question is being asked and what the numbers present to the actual question itself. Okay.